All right. So if you don't have any question, we can just go forward. All right. So today is introduction. Introduction. So we are going to talk about what drives big data, the characteristics, and also give you some idea landscape about the technology towards big data. Okay. And we'll show you many possible applications. And then we'll talk about uh, some big data concepts, the basic concepts, like different data models, and the process um, generally that let us to handle big data, and also some concepts about data analytics. All right. So here are actually some open questions. So again, as I mentioned, feel free to ask questions, and if you want to discuss more, just let me know. So here on the right top, okay, it shows a figure with all kinds of terms like big data, artificial intelligence, machine learning, data mining, right? So frankly speaking, nowadays, uh, it's very hard to clearly separate these terms. They have overlapped areas. And in this subject, we focus on big data computing, right? So what is data? So basically everything that we can get in touch nowadays, especially in this digitalized world. So everything is data, right? So for example, when you use your mobile phone um, to chat with somebody, right? You generate text data. And if you go to some social media like uh, Weibo, Twitter, right? So on these platforms, you get connected with others, right? This can be modeled as a graph. So everything we are doing nowadays, okay, they can be digitalized, and they can be used as data. So what is big data? What are the characteristics? Later in today's lecture, we are going to expand this a little bit to talk about the characteristics. But intuitively, it's big, right? It's complex, it's large. And another question is why we need big data, right? So actually, this is a very intuitive because when we use big data, we can create more value. The intuitive understanding is like this. So as an example, so when you open the WeChat app, right? When you see some post, you can read some article. Usually at the end, there are some recommendations about advertisement, right? So that advertisement is actually based on your history, based on, for example, your chat history or your browse history to uh, to recommend the relevant, to show the relevant advertisements to you. Okay. And for those big companies like Tencent, Facebook, Alibaba, right? This kind of companies, they're actually using this to make revenue. Okay, so for actually for these questions, they are open. Different people can have different understandings. I don't expect every one of us have the same answer. Okay, but roughly the idea is like that. So what are the relationships among these terms? Okay, so big data, machine learning, AI, data mining, right? So actually, for data mining, for example, this was a very popular term, like in 20 or 15 years ago, at the beginning of 2000. So, um, so that is to mine knowledge from data, right? So nowadays, AI is very popular, right? Everything is about AI, and everybody is trying to get themselves related or connected to this AI paradigm, right? So, but for AI, it's also similar. We want to use data to create value. We want to use data to generate knowledge or get knowledge, right? So the relationships among these terms are actually not complex, right? They are interrelated. They are overlapped. So now let's expand a little bit. Um, so here we today in this course we are talking about big data computing, right? And usually for big data, it means we need to have more sophisticated models, methods to handle that. And here, big, so it describes a kind of problem, a kind of situation that we need to handle big data. However, it is challenge. It is challenging. It's not easy, right? So, for example, if you have a small piece of data maybe stored in Excel form, right? You can just use Excel to process that. You can get all kinds of statistics. You can get you can even do some analysis using that Excel software. But if the amount of data is beyond, as I mentioned, the capacity of a single computer, if it's very large, if your algorithm is very complex with very high time-space complexities, then we need to think about how to solve this kind of a big problem. Okay. And here on this slide, I'm going to show you an overview about what we are going to learn. All right. This can help you to understand the logic, the structure of this subject. So later in this in today's lecture, I'm going to show you that we have different types of data to handle. And these different types of data, they are generated from different areas in different applications. Okay. Here at the bottom, it shows some terms about images, right? So when we use our mobile phone, we take pictures, right? They are images. And for images, we may want to use some ways to help us to make it look better, right? To identify the objects in images. So this all rely on some kind of algorithm or models running behind. And also text, social networks, GPS, spatial geometric data, and also time series data, and the transactions, and some biological networks. So the point here is that we may in the future in your career, you may join different companies, right? You may go to different industries. You may need to handle different types of data. Okay? But there are the data models behind the data that you are going to deal with are actually mostly included here, okay, for all kinds of different types of data. And with this kind of data, we want to create value, right? We want to analyze them. We want to utilize them in all kinds of applications in different domains. So, for example, for time series data, this kind like the stock price changing over time, right? So that's kind of time series data. This can be used for in fintech, and for the for the GPS data, this can be used for smart city, for intelligent transportation, and so on. Okay. For social network, we are very familiar with this, right? So we see all kinds of advertisements. We go shopping online, right? On this kind of social platforms. there are all kinds of algorithms running behind the screen, analyzing all kinds of user behaviors, product information, so to make recommendation, to post advertisements, to recommend friends, right? So basically, we want to use data to create value in these applications. So first, we need to use all kinds of algorithms, models to do data analysis, right? Yeah, you are in DSA, of course, so you you may have already learned a lot about data analytics. And so here we are talking about this in a computer science perspective. So there are many algorithms like graph algorithms, association rules, clustering, community detection, and so on. So there are many topics, and we'll cover most of them. And one important term for this subject is about big data computing, right? So it's not just to handle data, but also we want to talk about how to handle large scale data. So we need to have very powerful infrastructure. We need to have very powerful platforms or systems to help us to store, manage, process um, large-scale data efficiently. Okay, using maybe more than one server. All right. So we need to rely on these different storage or computation infrastructures like Hadoop, MapReduce. So you may not know these terms at this moment, okay, but later when we go to the corresponding lecture, we'll talk about them in details. Okay, we have all kinds of databases. We have Spark and Hadoop for different purpose of distributed computation. Okay, so this is an overview about this subject. So it's about data computing and also big data computing. All right. So you're welcome to ask questions, to interrupt me. All right. Okay. So I'm just curious, uh, because you are in a DSA program, how many of you have learned, how many of you are from computer science in your undergraduate study? Anyone? Okay, I see someone, right? Okay, great. Then most of you are not may not be from computer science, right? Maybe from mathematics, or from other majors, right? So the point is we have very diverse backgrounds, and all the students, so they may from different places, they may from different major. So so if yeah, if it is very fun or good to ask questions if you think there's something that you don't understand, or if you think you want to discuss something more. All right. Okay. So for today's lecture, it's mostly about introduction. Okay. So there are some concepts, terms. Uh, we will try to make it easy to understand. So now let's move forward. Uh, Here, in this figure, it actually shows some relationship between the business value and the complexity of the analysis or computation that you need to do. Okay, it's actually not complex. Where actually the intuition is like this: we want to have higher value in our applications, in business, all kinds of things, right? Um, then we need to rely on more and more powerful, effective ways, methods to do so, right? Usually for more powerful methods, they are they are more complex, right? So the value and the complexity, these two are positively correlated. And in the maybe like 15 years ago, business intelligence was a very popular technology that is to use the data to analyze data to generate value. But at that time, as I mentioned, mostly for these applications, they rely on data mining techniques and they rely on a small amount of data to do analysis. Okay. Nowadays, we want to do more powerful things, right? For example, for large language models, right? We all I believe everyone of us have used, for example, ChatGPT, DeepSeek, right? Kimi, all these kinds of large language models to help us to get knowledge, to answer our questions, to do all kinds of things, right? So in order to, for example, train a large language model, it relies on maybe tens of thousands of GPUs to work together, right? To handle very huge amount of training data so that the complex models within large language model can be well trained to learn from the training data. This is actually very complex and also very expensive, right? It may cost millions or hundreds of millions of dollars to train one large language model, right? So it involves all kinds of techniques, including but not limited to machine learning optimizations, analysis, multimodal data processing, and so on. So this is so if we want to have very high value in an application, we need to rely on all kinds of techniques, okay, and also all types of data, for example, images, videos, text, graphs, and so on from different sources. And for applications of big data, actually there are many applications. We cannot exhaust all of them, okay? So here we are just uh, providing you some examples, some different categories, okay? And I will just pick some as an example. Um, so for example, for customer analysis, um, we are all customers, okay? For example, when we go to Taobao to buy something, right, we are the customers. And when we use WeChat to chat with a friend, to read articles, to watch videos, we are also customers, right? All our behaviors, all the data generated surrounding us, they are used to create some user profile for each account. And these companies, they use these kind of customer profiles to do recommendation about products, friends, and so on. We already mentioned this. Um, and also for data analysis, this can be used for security purpose. So for example, you can do anomaly detection or fraud detection to check if there is some security issue or not in a system, to check if there is some attack to the network, right? This is about cybersecurity. And this can also be used for operation analysis, that is to improve the efficiency of operational tasks, for example, in a big company. And if you know what a data warehouse is, this big data analysis can be used, okay, to increase the capacity of data warehouse. Okay. So there are many things, and also for the big data, this can be used for visualization. That is to visually show the insights or the summary of huge amount of data. So let's just take a customer analysis as one specific example to expand it. So here, this shows a screenshot about Amazon. About on Twitter, for example, on Taobao, it's similar. So you have products, right? And you, as a customer, want to buy something. So you just go browse or search the relevant keywords to find the products that you want. And also you may check the reviews of these products, right? Um, Actually, all these kind of data, they are useful. And in particular, for the relationship between users and the items, the products, okay? We can model them as a bipartite graph. So here, uh, in the example here, this shows you a illustration about what a bipartite graph is. So intuitively, there are two parties, item and user. So for the items and users, for each of these entities, they are represented by one node. So this is one node, okay? This is also one node. And on this e-commerce platform as example, uh, the connection or the edge between one item and one user may represent the purchase relationship. So if there's an edge connecting user, for example, for this user A, and for this item 1, there's an edge connecting them, right? So this means this user has purchased item 1. And so this one edge represents one transaction. So on this platform, there may be numerous transactions, right? So for every one of us, we buy lots of things on the network, on the e-commerce platform, and also there are many platforms, many items purchased by different users. So this actually form a bipartite graph with item nodes, user nodes. They are connected by edges. Here in this example, these edges representing the purchase relationship. Okay. And then if we want to do recommendation, one very intuitive idea is that for two users, if in the past they buy lots of similar products, right? And then for this user A, it purchased product 1, and this product 1 has not been purchased by the other user. Then we can just recommend this item 1 to the other user, okay? Because these two users in the past, they purchased lots of common things, so they have common interest, right? So this is a very straightforward intuition. Of course, in real world, for this kind of application for customer analysis, it's much more complex. It involves not only this graph structure, but also the text, the attributes of users, and also the items. And here is another example that about real-time information discovery. Okay, so that is we want to know, especially in some very critical scenarios, we want to know immediately what's happening. Okay, what is wrong with a certain kind of urgent situation. Okay, so this also relies on the analysis of data, and also we want to get a timeline about what happened, what has been processed, what is under processing, what are the possible consequences, and so on. Okay, so this is actually a very important technology in these applications. So actually, there are some companies doing this, okay? And also, for example, we want to monitor what is going on the network for a certain specific topic, right? So that's also about real-time information discovery, and this relies on going through a huge amount of data to find the relevant small pieces of information that we need. Here is another example about transportation. So this is related to the GPS data that we mentioned. Okay. So we all know how to use a map, right? So when we use a map, we can go to any place. We just follow the routes provided by, for example, Baidu Maps, Gaode, or Google Maps. Uh, so here it shows a more specific situation that is on this map. All right. For the green curves, okay, dynamically changing, it shows the trajectories or traces of taxis in a city. Okay. So as time goes by, so it's in the morning. For the taxis, how they move. Okay. And for this is actually some kind of visualization, and I believe we can identify some very interesting pattern, or we can already get some insights by ourselves when we look at them. So firstly, that for from the airport, most of the taxis they go to the city, right? This this is a one possible insight. And the second, they follow some major roads to go, right? So this is to visually show you some insights about this tax trajectory data. And what we can use this, for example, to monitor the situation about the traffic flow at a certain time, right? And also based on this historical data, we can do analysis to identify the possible, for example, intersections that that are easy to be congested. Then we can use this to do urban planning. That is, for example, we may propose to open a new road, right? We may um, build some new highways, right? So these are all rely on the analysis of historical data. In this example, it's about the tax trajectories. And also, if you uh, think in more details, for this kind of trajectory data, right? So just imagine you are on a taxi, so the driver is driving you to your destination, right? So for every second or for every 5 seconds, you are at a different position, right? Which means for every 5 seconds, you are at different GPS coordinates. And for these coordinates, they are also associated with the time, speed, and so on. So this is actually some kind of GPS data, also some time series data. And this is only one trajectory for one taxi, right? So if you have the trajectory data of all the taxis in a city, then you can do a lot of things about understanding the traffic flow of the whole city at different time, and also to do the urban planning as we mentioned. So this is actually very powerful. So we can observe traffic patterns, okay? And also we can use such kind of historical trajectory data to improve the mobility in a city. For example, we can use this to design a better traffic light plan. So at some cross, we may wait for a very long time, right? So if we have better traffic light plan, we may have higher efficiency for movement. And find out the road with a heavy traffic. So design new route. We already mentioned this. So another example is about AlphaGo. This is how to say it. So this is already very classic example happened, I think it's, I believe maybe 10 years ago, but AlphaGo is actually, you can regard it as the starting point of this recent AI move. All right. So for large language model, they got very popular in recent 2 or 3 years. But before that, um, there's some uh, uh, some very popular technology related to AI and also big data. Okay, and AlphaGo is a very representative example. So basically, the idea is for this Go game, uh, uh, Google designed some kind of a program that can software that can excel uh, human experts. Okay, they perform better, and this is actually a very complex problem to solve. So on this playboard, right? So you play white or play black. Uh, there are many possible choices for you to make each step, right? And AlphaGo actually learns from millions of moves of thousands of historical games played by experts. So here it's also about big data because the amount of historical data is large. AlphaGo needs to use machine learning algorithms and also optimization algorithms try to decide next move efficiently. Okay. So for example, if you are playing with AlphaGo, you don't want to wait AlphaGo for like 10 minutes for each move, right? So AlphaGo can actually respond very quickly. And this is actually, as we mentioned, on this. So here, you don't need to understand this example in very details. The point is, you just need to get the idea that this is actually a very complex problem. So this is a playboard. Just imagine that this is a simplified playboard, and we play black or white, right? So suppose that currently there's a black stone here, and if you want to put a white stone, as you can see, you can put that white stone at any other positions in this playboard, right? So you have many choices for this one move. Uh, let us make it easier to understand. So for example, in the first step, you have 100 choices, 100 positions as choices. And then for the next move, you have another 100 options, okay? So just for these two steps, there are going to be like 10,000 situations, right? Different situations. And if you go play further, maybe you play like 100 steps, then that number is a very huge number, okay? And for AlphaGo, it needs to consider all kinds of situations, all kinds of these different ways to play this game, and identify the choices with the highest probability to win, right? Okay. All right. So let's see another example. After this one, we may have a break. Okay. So here shows some example about Google search engine. So on this search engine, we want to search something, we just type in keywords, right? Actually, this can already reveal lots of things. So for example, here, this shows the interest by subregions in different, for example, states about different topics, okay? And here in this example, it is about COVID-19, okay? And as you can see, for different states in this map, they have different level of blue, showing that these different places, they have different interest in this topic. Okay. This is just one example. You can change to other keywords to find the popularity or interest of these different topics in different regions. And actually, this is a very interesting and important uh, application by Google Trends. There was one very important finding, that is to use this keyword search, the trend of this keyword search, to predict flu trend. Because for flu, it actually um, propagates from one place to another place, right? So Google tried to use this kind of keyword search trend to make predictions about the trend of flu. So the idea is very simple. So if in one place many people are searching about flu, this means in this place maybe many there's a there's a flu situation, right? And then later from this place, the flu goes to another nearby place. Then in this new place, many people will start to search this keyword, right? To find a cure for that disease. So the idea is like this. So by trying to follow the change or the trend of these searching keywords, this is actually correlated to the propagation of this flu. You can find more information about this application on the web. So this flu trend prediction was actually some example about the power of big data. Try to just use the correlation between keyword search and the flu propagation. So with this, we can just rely on a data scientist with a little relevant expertise to predict the spread of flu. And this is actually accurate than some experts in disease control. Okay, so let's have a 10-minute break and then we will continue. Continue. I think we just spent a significant amount of time to talking about all kinds of applications. So, okay. So in the following for similar content like about applications, I'm going to be brief so that we can go to next part about today's lecture. So here, yeah, so for this example, I will just get you the idea. So, so here is something called AlphaFold. That is to predict um, the structures of proteins, these biological units. So in the past, okay, before AlphaFold or before this uh, this model, actually it's a very how to say it? It relies on human experts to design different protein structures, okay, to explore the and test the characteristics, the behaviors of different potential protein structures. But with this AlphaFold, okay, we can synthesize and generate many huge amount of different protein structures and also predict the characteristics they may have so that we can explore a huge search space about these potential protein structures to design new proteins. Okay, this is very useful for example, biological analysis, for drug design, and so on. So the point is, so there's a database uh, about protein structures. Okay, and it may contain huge amounts of data here, and rely on the learning models. We can predict, okay, the structure of proteins, for example. Okay, so here shows you a YouTube video. If you are interested, you can go and watch this. All right. Big data can also be used in fintech. So, for example, to detect fraud. For example, fraud claims in insurance. And also, this can be used for suspicious email detection, for account takeover, ATO detection. And also, this can be used for high risk MCC here. MCC is a merchant category code. This is a kind of a code for certain merchant. They will, to detect the risk level of different merchants. And also, when we open a bank account, when we apply for credit card, actually, these different banks, they also analyze our profiles to identify if we are high risk or not. And this also we can do money laundering detection by using graph algorithms. Okay. And also fraud detection in transaction networks. So there are all kinds of things that we can do in fintech for fraud analysis, for risk management, and so on. So there are more applications. So I just list these possible application areas here. Okay, if you are interested, you can search these keywords online, okay, to find more information. Okay, for example, this for near-Earth object detection analysis, right? This also relies on the efficient and powerful analysis about the data that we observed, okay? Because there are many objects in the space, right? So we need to have some very efficient way, for example, to predict the moving trend or the possible trace about certain objects moving in the space, right? So there are many things, okay? As I mentioned, you may join different companies, you may go to different industry. So in the future, you may find that, okay, you need to always deal with data, right? Okay, so yeah, nowadays we are surrounded with all kinds of data like video, images, right? Streaming videos, live live podcast, text, right? Uh, moving trajectory, GPS data, and so on. So we want to try to define what big data is. But here I want to clarify that this definition is not that well defined. You can just regard it as some description instead of calling it like a definition, for example, in mathematics, right? So in mathematics, if we have some definition, it's very accurate, clear, and concise, right? But here for big data, yeah, you can just regard this as uh, some some way to describe the characteristics about big data. Okay, first is a large complex, right? And it may involves the information extraction, the data processing, and so on. And there are many challenges in order to deal with big data, including how to capture data, right? How to store, how to analyze, search, share, transfer, visualization, how to query the data to get the information that we need, and how to update. the data. So for example, in our bank account, right, we have our money in our bank account. And if we do some transaction, these numbers should be updated correctly, right? We don't want to have anything wrong with our money. So we need to do proper updates about data and how to handle dynamic data and so on. There are also privacy issues, and also the data may be from different sources. As you can see, for big data, it's not just about the amount of data, right? So it basically involves the challenges in the whole life cycle of data, right? Include from the generation, capturing to the uh, analysis, querying, update. So here, furthermore, explanation about the characteristics about big data. Um, it's a long text, okay? But the point is, we want to use data for getting insight to make decision. So let's just go to this part that is what we choose to focus. That is about the 4 V's of big data. So before talking about this, I can let you know that you can search more information about the characteristics of big data. Here we are going to only talk about these 4 terms here, 4 V's. You can find more V's to try to from different perspective to describe data. Okay, but here let's just focus these four parts. The first is about volume. All right. So volume is very easy to understand. Basically, the amount of the data that we are dealing with. So you need to be familiar with these different units to describe the scale or the amount of data. I believe we are very familiar with this gigabyte, right? For example, in your laptop, you may have memory in, for example, 32 gigabytes, right? And your disk maybe have a capacity of 500 gigabytes. Okay, when we talk about gigabytes, it's this one. Of course, we may have a decimal or binary way to describe these different units. Okay, they are similar with a very minor difference. Okay, so for example, for 1 gigabyte, it's 1,000 to power 3 bytes. Okay, well, if we describe it in a more accurate way within a computer, it's 1024 to power 3 bytes. Okay, so so 1 byte is a very basic unit in a computer, okay, to describe the space or the amount of data, okay. And if you want to learn more, there's also something called the bit, okay. This is the atomic unit within a computer, okay, the lowest level data unit, okay. So usually 1 byte is 8 bit, okay. And then for 1 KB, that is 1,000 byte, okay. For megabyte, that is 1 million byte, okay. For 1 gigabyte, that is like 1 billion bytes. All right. And beyond gigabyte, we also have terabyte. Okay. So as you can see, for this KB to MB to GB to TB, their difference is 1,000 times, right? For example, maybe you have a very powerful computer and your disk may be in the capacity of 1 TB, 2 TB. That's also very common nowadays. And beyond TB, we have petabytes. 1 petabyte is 1,000 TB. Okay. And also, if we go larger, we have exabytes, zettabytes, and also yottabyte. All right. So nowadays, every year, for the data generated in the world, it goes to the scale of zettabyte, ZB. All right. This is a very huge amount of data. And for these big companies like Tencent, Alibaba, Google, eBay, Jingdong, and so on, so they need to handle a huge amount of data every day, in for example, in hundreds of petabytes. Okay. So here, as you can see, one petabyte is 1,000 TB, right? So actually, this is a huge amount of data, and the amount of data to be handled every day is also growing. So you get the idea that nowadays, for these big companies, the data volume that they need to deal with is very big. And then also we have mobile phones. We generate data all the time. And also nowadays modern cars. So for nowadays, especially for the electric vehicles, they have all kinds of sensors, okay, electronic devices on the cars, right? And these sensors, these devices also generating uh, data to be used, to be analyzed for example, for smart driving and so on. And also for scientific analysis, scientific study, there are also devices like this. This is something called a hadron collider that is to study physics. They try to let the atoms to collide with each other to observe the phenomena and so on. So they actually, for this kind of experiments, maybe every second, okay, 1 PB data will be generated. So we need to do analysis. The scientist needs to do analysis on that. So that's about volume, all right? The second is about is called velocity. That is, it actually contains two aspects for velocity. Firstly, the speed of data generation. We already have the idea about this. So in this figure here, it shows that in every minute, for example, in every minute on YouTube, 48 hours of video is uploaded, right? So it's this is just 1 minute. If it's one day, then the number of hours of videos uploaded is a large value here. So this means all at every minute, every hour, every day, we are generating data in a very fast way. And another here shows other examples. For example, when we take a flight from here, maybe go to a destination, right? And maybe this flight is a 3-hour flight. Within these 3 hours, also huge amount of data is generated in a very fast way. Okay, and we need to respond to this data quickly to see if everything is fine with this flight, right? The logistics, the passengers, the devices, the sensors, the stuff on the plane, is everything good, right? We need to monitor this to analyze, to generate data. So that's about the speed of data generation. The second is about the speed of data processing. This is also related to velocity. That is, we want to process the data in an efficient way, in a timely way, right? So, for example, in online data analytics, we want to make timely decision, for example, for recommendation. If we have a very slow algorithm to make recommendation, this may means missing opportunities in business. For example, as an example here, suppose that you are running some location-based services to do, for example, recommend nearby stores to your customers, right? In this scenario, the common task is to, based on your current location and your purchase history, to send promotions right now for the stores next to you, right? So for example, now you are at PolyU, right? So it's meaningful to recommend nearby stores to you, right? So this analysis needs to be done in an efficient way. So if, for example, 2 hours later, you leave PolyU and go to some other place to have fun, right? So you are in a distant place, then it's meaningless to recommend stores nearby PolyU to you at that time, right? So you get the idea here. And also for these critical applications like health monitoring, we want to analyze the sensor data in a fast way so that we can notify if there are some abnormal measurements or not, right? So this is about velocity, so the speed of data generation and the speed of data processing. And a third example is about money laundering detection. So we don't want to spend several days to signal the potential fraud transactions, right? We want to do this as fast as possible. Okay. So the third is about variety. That is, we may need to generate, collect, and process many different types of data. So let's think about one example in an email, all right, in the email. So in the email, usually you have the email title, right? And then you may have some text content as the email body. And in the email, you can also attach document, attach image, right? And in the email, you can also draw a table to show a table of content. And also in the email, you can include some hyperlinks to some web pages, right? So even for this email application, it's a very, email has been there for decades, right? It's very classic. We use it every day. We already get used to it. But if you think it carefully, you can see that, okay, even for email, we may deal with many different types of data, including tables, right? Tabular data, text, images, hyperlinks. Okay. So this means, for example, for spam email detection, if you want to do spam email detection, you need to consider these different types of data, right? So there is a high variety in the types of data that we need to handle. This means for these different types of data, we need to have different data models to describe them or to store, manage them in a computer, right? We need to use tables, relational databases, text, semi-structured data, graph data, and so on represent them. So yeah, so you can come up with many other different types of data we may not mention here, like a video, like audio, right? Uh, yeah, there are many types of data. Very soon we'll expand that about data model. So the fourth characteristic is about the something called veracity. This is related to the uncertainty of data. And this is also easy to understand. So, for example, Now you have maybe you have some data in your hand. The very first question, uh, because you want to use it, right? For example, for your business, the very first question is, okay, where is this data from, right? What's the quality of this data? Is it complete? Is it reliable, right? Is it meaningful? Should we use it or not? Will this create value for our business, or will this uh, mislead our business, right? So these are kind of questions that we should have whenever we have some new data coming in. Not all the data they are from reliable sources. Not all the data are complete and useful. Uh, the point is, so for the data that we are handling, they may not be accurate, right? There may be error within the data. They may be misleading. They may be not reliable, not trustworthy. So, so yeah, so veracity is about the uncertainty of data. Okay, so maybe for the data there may be some measurement error, some human error like typo and in names and addresses, for example. Okay, actually this is a very common uh for to ask these questions. And when we want to do analysis about data, I think in for most of our effort, okay, our time, okay, we spend to make the data clean, make the data integrated, make the data useful. Okay, so this is a veracity. So we just finished talking about the characteristics about big data, the four ways. We focus on these four aspects. Okay. Now let's see some technology towards big data to give you some idea about usually how we about the methodologies, okay, that we handle big data. So here on this slide, generally speaking, there are three strategies, high-level strategies. First is called scale up. So this means, so for example, initially you buy just one server, maybe not that high end, okay? Maybe you just spend like $10,000 to buy one computer to process the data that you need, that you have, right? Later, if you find that, okay, this computer is getting slow, right? It's not powerful enough to deal with my growing data with complex algorithms. Then you decide to spend maybe $30,000 to buy a new, more powerful computer, right? So you spend more and more money to buy more and more powerful machines to do the computation. So this is the so-called scale up. Okay, so you just use your money power to do it. But of course, everything has a budget, right? So we don't have unlimited money or budget to always buy the latest, the most powerful machines. Another more common situation in real world is that, okay, maybe today, maybe in the past, you have already purchased like 3 or 4 computers, right, at different time. And they are not that powerful, right? For each computer, they may be a little bit outdated with a moderate computational power and capacity, but you don't want to just throw them or leave them there without using them, right? You still want to use them. So here we need to let these 3 or 4 computers to work together as a whole, as if they are just one computer to deal with the data analytical tasks, right? And then you have this cluster of 3 or 4 computers to work together for one task. And later you may buy another 2 computers And you want to add that two computers into this one cluster so that you can scale out, okay, to have a cluster with more and more computers to work together for the for one task. Okay, so this is a so-called scale out. So that is you have um, more and more computers to work together. Okay. So another, the third strategy that is we want to design new algorithms, new solutions that is more efficient and effective. Okay. So for the first two aspects, it's like you spend more money to buy more devices, right? For the third one, that is you use your idea to design a new algorithms, okay, to be more powerful. Maybe some new algorithm with a lower time complexity, but getting the same result, right? So yeah, so here are the high-level strategies to deal with big data. And for algorithm design, it's actually an iterative process. That is, you design algorithm, you analyze it, you implement it, and you do experiments, you refine it, and so on. Okay. And in previous slide, we just show three high-level strategies, right? But if we break them down into details, there are actually many techniques that we need to rely on for this purpose, including parallel computation. So parallel computation means you have multiple computers, right? And within each computer, I think nowadays, for example, in your laptop, you may have maybe one CPU with 16 threads, right? And one thread is a computational, how to say it, worker to do computation by itself. So if you have 16 threads in your laptop, which means you can let these 16 threads to run in parallel to do computation in order to speed up the task that you are dealing with. Okay, so within a computer, you can have parallel computation, and then if you have more than one computer, you have this so-called distributed cluster of multiple computers, each with multiple threads, right? As you can see, this is a complex architecture to do distributed parallel computation. And also for data storage, right? We may have multiple disks to store data, right? And in order to let different computers to communicate with each other, we may rely on high-speed network connections between these computers. Okay, so there are actually many things, and also as another example, for example, for machine learning, right? So suppose that we have a machine learning model here. We just call it model A, all right? To let it run on one computer is very different from to let it run on multiple computers together, right? So that's a distributed machine learning. Okay. So yeah, so for this, as I mentioned at the beginning, for this subject, we'll try to cover some architectures about parallel and distributed computation, but frankly speaking, because we only have 13 weeks and we cannot cover all the uh, topics, especially the emerging techniques for this huge, big research area. All right, but we'll try to let you know the idea and the techniques as much as possible. So here, on this slide, we show you some landscape about big data to provide you some idea about, okay, so what are we talking about for big data? So in this, how to say it? So in this figure here, for every logo, in this figure, it actually represents one industry or one company, okay, representative company. Let's look this figure from bottom to the top. All right. At the bottom, we have the fundamental infrastructure layers, the layer with Hadoop, for example, or Cassandra, this kind of storage or computational platforms. On top of that, we have analytical infrastructure to do all kinds of analysis. And also we have operational infrastructure and also infrastructure as a service. So for example, Amazon is a cloud service provider, okay? So it provides computational and storage infrastructures to its customers, okay? And also we have all kinds of databases. And then as you can see from the bottom to the top, we are moving from the fundamental infrastructure to the applications, towards the applications. So we also have data providers. So there are many companies doing this kind of business. That is, they try to provide data as product, okay, to sell data to other customers. And by using the infrastructure, there are also companies doing business intelligence and also visualization, as well as designing some apps, okay, and also provide log data analysis. Of course, this is a figure only shows you these different areas and also different companies. There are many other companies doing business surrounding big data, okay? And they rely on different technology to do so. All right, so I think that's finishes the introduction part of today's lecture. So now let's go to some concepts, okay, basic concepts. Okay. So if you have any question, feel free to ask. All right. So we are going to talk about the concepts about data models and also the process of big data. So yeah, first, let's look at this plot here. This shows the types of attributes or the values that we may encounter. So for example, we may have numerical attributes, right? Just numbers, right? The age, right? The height, the salary, right? They're all numerical values. On the other hand, we may have categorical values. Okay, so categorical it's for example, the color of our hair, right? Black, brown, yellow. So these values are categorical. And then for categorical, we can break it into subtypes, including the ordinal values. Ordinal means they are categorical and have a meaningful order, right? So for example, ABC, grade, right? So A is better than B, B is better than C. So there's some order here. And if the categorical values, they don't have meaningful order, this is called nominal values, like the color, right? Black, brown, blue. And if we only have two states for the nominal values, so just true and false, for example, okay? So this is called binary, or 0 and 1, right? Absent or present. right? So this is a binary value. That's about the attribute type. And in the following, we are going to mention this, we are going to explain these different data models, okay? Let's just go to the first one. It's called relational data. So when you see this term, relational data, don't get scared about it, okay? So intuitively, you can just interpret it as tables, okay? Just tables. So we know what tables are, right? In a table, we have rows, we have columns. So that's it. Okay? So it's a table. Uh, in a relational database, that this is called relational data, and in Excel, in CSV, we all in all this kind of software, we deal with tabular data, right? In table form. So in the table, we have columns, right? Each column, you can regard it as a feature or attribute, right? So for example, in this column, uh, this is a column about first name, right? And this is a column about age, right? And for this age, it is attribute in a numerical type, right? And each row in a table, we call it instance or a tuple or a record, right? So for example, for this row here, it's about one person. Smith, the name, John, the first name, city is city code is 3, age 35, salary 280, right? So as you can see, this is one instance about one entity. And usually for the first row of the table, this is the header of the table, right? Shows the information about each column. And relational data or tables, they are very common to describe, for example, product information, student information, sales figures, human resources, customers, right? They are very common. So actually for tables, they are very easy. They are the most common format for us to model data, right? And they are very important in many areas. So for the second data model we are going to mention here is about text data. This is very natural for us, for human beings, to understand. For example, for this one, so John likes to watch movies, Mary likes movies too, right? So we have two sentences. So this is text, nothing special here. And if we expand the scale, right? So for example, if you submit your report to me, which means I may have 50 reports, right? So I have 50 documents, each containing a huge amount of text, right? So and another example, for example, in if for if for a lawyer, right? Uh, he or she needs to understand lots of legal documents, right? And we also rely on nowadays, for example, computer machine learning models, large language models to help us to 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 understand documents, legal documents, contracts, and so on. Okay. And for text, we can actually do lots of things. First is that for two documents, we can analyze their similarity, right? This can be used for detection of pleasure to see if they are too similar or not, right? This text can be used for sentiment analysis to analyze people's attitude towards a certain topic. Are they positive, negative, or neutral for a certain topic, right? And we can also use this for search. So one very simple example we already mentioned, for example, on search engine, you just type in your keywords, right? And the search engine will return the most relevant web pages to you. Your query keywords, they are text, right? And the web pages also contain text. The next one is image or video data. Okay, so for video, it's like for one video is just a sequence of images. So here we focus on talking about images. So look at this example here. This shows you a image in grayscale, right? Maybe it's a coffee or with some food, right? This is in grayscale. Look at its shape. It's like a rectangle, right? So in a computer, we just store this as a matrix of pixel values. And for each pixel position, there is a pixel value representing its grayscale in this example. So just a toy example. For example, for this area, right? For this rectangle, square, small square here, it may be represented by a 3 times 3 pixel matrix. Okay, with these pixel values from 0 to 252, 55. Okay, so for different pixel values, they represent different gray level. 252 means white. Okay, 0 means black. Okay, values in between will representing the grayscale. Okay, from dark to light. This is a this is a image in gray. So what if we have image in color, right? On the right hand side, one example here. So it's a picture about vegetables, right? With a different color. So here we in one image, we have a different format for colorful image. But they have similar ideas. So let's talk about RGB image. RGB means red, green, blue. Okay, and so in this image we will have 3 channels, each for red, green, and blue, respectively. So maybe this is for red, this is for green, this is for blue. Okay, we have 3 channels. And for each channel, for example, for this small part, for each channel, we have a pixel value matrix. So here, this is the pixel matrix for R, and this is for green, this is for B, and they combine together, representing this small area. So as you can see, in a computer, on the screen, we see many different things, right? On the screen, we may see video, image, we may see text, and so on. But at the bottom in the computer, they are just stored in numbers, okay? And for these images, for example, for us, for human beings, we can easily see that, okay, so this is an image about vegetable, especially pepper, and we know the position of these vegetables in this image, right? But we want to do this automatically by computer, then we may rely on image segmentation, object detection, and so on, different techniques, okay? Another example is about audio, voice data. So when we talk with each other, right, when we speak to another person, we are actually also generating data, okay? And when we watch a video, right, when we listen to some podcast, that audio is also some kind of, how to say it, Specifically, that is sequential data, a sequence of signals. Okay. So our voice stored as audio data, it is a sequence of signals. Okay. So this is somehow some kind of time series data. Okay. And for this audio data, this can be used for speech recognition, for speech to text conversion, and so on. Okay, there are also virtual assistants. Nowadays, this is very common, right? Because of the large language model, virtual assistants, they are very common, and they can be used to help. They can be used to help us to do lots of things. And also for each of us, our voice is also unique. So this can be used for biometrics to authenticate the access to a certain resource. Now let's look at the next one. It's a graph. So here the graph is not image, all right, not figure. Graph is a kind of a topological structure. It consists of nodes and edges. We already explained something called bipartite graph, right? In the application. So here, generally speaking, for graph, it contains a set of nodes, and these nodes, they are connected by edges. So for example, here, we have a group of people, and some people, they are friends, some people, they are not, right? So we have a small group of friends, another small group of friends, and these two groups may have common people, right? So, for example, in this social network, we have these users, and they are connected by friendship edges, right? So, in this way, we have this topological structure. Nodes can access each other by following the edges. Okay. So for example, let me see. This one for this user is a friend of this user, right? And for this user, she is not a friend of this user, but they can be connected by multi-hop, by a path with multiple edges, right? So this is a path connecting them. So later we'll have one specific lecture talking about graph algorithms. And also, so another example is about transportation network. So we have road segments, right? When we want to go from one place to another place, there must be a path, okay, following the road segments and intersections to go from the source to the destination. Okay. In this example, you may regard the intersections, the crosses as nodes, the road segments as edges. And for transactions, for example, we purchase something online. Actually, this may link us to the products and also to the banks. Okay. And if there are many transactions together, we have the transaction network. All right. So let's have a 10-minute break and then we continue. Okay, so yeah, let's start. Okay. Uh, so we were talking about graph data, right? So let's see this simple example here. So we can easily see that, okay, in this graph, we have four nodes, right? One, two, three, four. And also four edges connecting them, right? And also for these different edges, we may have some weights on edges. And in some cases, we may have weights on nodes. So here shows the weights of the edges. And this weight maybe, for example, represents the distance from node 1 to node 3, right? It's 4.3. The distance from node 2 to node 1 is 1.2. Just an example here, right? It may represent distance or cost or the closeness between two users and so on. So there are many scenarios that we may rely on weights, okay? So using this example here, this is a visualized plot of this graph, right? But in a computer, definitely we only have numbers, right? So this can also be represented by a matrix, okay? And this example here, this is so-called adjacency matrix. So if there's no edge between two nodes, the corresponding position has value 0. Otherwise, if these two nodes, they are connected by an edge, the corresponding value is the weight of the edge. So for example, this 0 means there's no edge between a 4 and 2, okay? So this value means there's an edge between 3 and 1 with weight 4.3, okay? And in this example, this is a so-called undirected graph, which means there's no direction on the edges. And we will have this adjacency matrix in a symmetric form. Okay? And there are many other ways to store graph in computer. We can just store a list of edges. So it's like it's a name. It's an edge list. So in this list here, each row represents one edge. So this is the edge between node 1 and node 2 with weight 1.2, right? This is the edge between 2 and 3 with weight 0.8. Okay, so this edge, right? So you just have a list of all the edges. You also have the graph stored here in the computer. For the graph representations, we will talk about them in more details. Okay, this here we just give you some idea. And for graph data, this can be used for like recommendation, customer relationship management, fraud detection. Okay. And here is another example. The other next data model is spatial temporal data. So for spatial data, it's basically the positions or GPS coordinates. And temporal data, which means we may have timestamp, temporal information associated with locations, right? Just to show you this example here. In this figure, it shows, yeah, on a social media, for example, WeChat or Twitter, now called X, right? So we can post some text associated with our current location, right? For example, currently I'm a next view, right? You post an image, and then under this image there may be a location associated with it, so that people know, okay, this is the place that you take this photo. This is so-called check-in operation. So if, for example, you as a tourist go to a city and you just take photos at different sites, different places, and post your position at these different places, this will also naturally form a trajectory, right, of you as a tourist, right? For example, here, for this tourist with a trajectory 1, it may visit this city and go to this 4 tourist sites, right? So this forms a trajectory. So these tourists go from one place to the other, to another, and so on. Here is another trajectory for local people, for example, maybe yeah, for local people, only 2 places. Maybe one place is for he or her home, the other place is the workplace, right? And you can tell that these 2 trajectories, they are very different. If you are a tourist, you go to a city, you tend to go to diverse places, right? Because you are visiting there. But if you are a local person in a city, you may just go from your home to your office, right? So the trajectories of different people are very different. So put it in the other way, if we have some trajectory data and we observe that, okay, so for this user, in this city, its trajectory is very diverse, containing different locations. Then we may make a prediction that, okay, this is possibly a tourist, right? If we have a regular trajectory for another user, we may infer that, okay, this is a local person, right? Which means based on the trajectories, we can classify these users into different groups with different labels. Consequently, we may make different recommendations, right? So this is give you the idea about how we use tourist spatial temporal data to make such kind of analysis. Okay, so it contains space and time information. It's very important for understanding space-time factors and changes to classify different users. For temporal, yeah, okay, we already mentioned it. Okay. The intuition is that uh, the observations are close in time or space. They are, which means this usually means they are similar, right? So for 2 users, if they follow the same trajectory every day, they are very similar. That's the intuition. Okay. This can be used for trend prediction. Okay, so we talked about different data models. Now let's try to summarize and a little bit categorize them into structured and unstructured data. So sometimes when we see that, okay, this data is structured, that data is unstructured, right? So what do these terms mean? Um, so we need to understand these 2 terms from the perspective of computer, not human being, right? Not us. We need to understand these 2 terms from the point of view of computer machines. So if the data can be easily understood by computer, it is structured data. If it's very difficult, it relies on substantial computation analysis to be understood by computer, that's unstructured. Okay. So the information is easily interpretable by machines, that is structured. The information is very hard to be understood by machines, that is unstructured. For example, we have 2 numbers, right? For example, 32 and 45, right? Which we have a table, for example, about ages, about salary of employees, right? These numbers, they are easily interpretable by machines. So this table is structured. Here shows an example, right? So this table is a very classic common to be processed. by a computer. So it's structured, it's easy to be interpreted. On the other hand, for example, for the text here, so this shows some information about the university and students, right? The university has 5,600 students. John's ID is number one, like this. So it's a text description. We, as a human, we can easily understand the meaning of this text, right? But for a computer, without relying on large language model, right? Without significant computation, so can a computer easily understand this piece of text? The answer is no, right? So this is unstructured data. So we need to think about structure, unstructured in the perspective of machines, not humans, okay? From our understanding, this is very easy to understand, right? From our capability, but for computer, it's very difficult to understand. So unstructured, structured, and in between, sometimes we may have semi-structured. So this is some format called, as example, this is called XML. So as you can see in this middle figure, there is some kind of structure, right? So the university, student name, age, but it's not in the table form, right? It's and also it may contain long sentences and text. Okay, so this is something in between. So for this subject, if you can understand the unstructured data and structured data, that's already good enough. Let me ask you a question. So for example, for video, right? For video or image, is it structured or unstructured? Right? So you need to think about that from a machine's perspective. We just talked about that for an image, it's a matrix of pixel values, right? If it's a matrix of pixel values, well, that seems to be structured. But to understand, to interpret that image, it's very challenging for computers to understand, right? Or what's inside the image. Is there a dog or a cat, right? Where is the dog? Where is the cat in the image? These are very difficult for computer to understand. So images, videos, they are unstructured data, all right? So, but in the real world, unstructured data takes most part of the data, okay, maybe 80%. Well, for structured data, structured data like tables, okay, they are very common, but they are only a small portion of the whole data that you may need to deal with. I already explained why images and videos are unstructured, okay? Uh, yeah, for this figure, if you are interested, you can look at them in details. Now let's go to next part. So here, we talk about this big data process in 5 steps. Of course, you can break it into other steps as a similarly. This is not a well-defined process, okay? It's not a very rigorous definition. We just interpret these 5 steps, okay? So for the first step is to acquire data, collect, store, retrieve, okay? We need to get some insights about the data. And this data may be from different sources, all right? And for the acquisition of the data, we will not talk about much about it, okay? Of course, if you know how to write a crawler, if you know how to collect data from users, then you can easily get them, right? And the next step is preparation. For this one, let's expand it. For the first aspect is called exploration. That is, okay, so you have some data here. Before doing a very heavy, expensive computation, you want to know get some idea about what data you are dealing with, right? What are the trends? What are the characteristics? So you want to do some preliminary analysis. For this one, we may usually rely on some statistical techniques like a histogram, like scatter plots to try to explore the data. For example, we may see that, okay, so based on this sample of data, we see that, okay, there's some correlation between these two attributes, right? There's a normal distribution about a certain attribute, okay, like this. After that, we may want to pre-process the data. As we mentioned, for characteristics of big data, the data may be dirty, right? They may be not reliable. We may need to integrate data from different sources. We may do some feature scaling, feature extraction to make that more effective for us. So this is related to data preprocessing. Data preprocessing is very important, right? The reason is also natural. It's if we have garbage data into a model like a machine learning model, then we will have garbage results, right? If we have high quality data to use for a certain method, we will have high quality result. Okay, this is natural. So data preprocessing is important. Let's look at integration. That is, we may have data from different sources and we want to integrate them so that we have a unified view. As an example, maybe we have maybe you have three supermarkets, right, at different locations, belonging to the same company, right? They have their own sales figures, sales numbers, and for this, and also they have their customers, and these customers may be overlapped, right? So you want to unify, you want to integrate this the sales data from these three different branches or supermarkets into one database, right? You need to combine them. You need to reduce the duplication. You need to consider all kinds of factors, okay, to make the data precise, accurate, and correct. Well, for data cleaning, this is related to the veracity of data, right? Data may be dirty. There are many possible issues. Maybe we will have outdated data, right? And we want to update them. Maybe we have duplicated values. Maybe we have invalid IDs. Maybe we have missing value in a certain cell. So for a certain entity, maybe there are outliers, right? And maybe we have invalid data values. So let's see example about data cleaning. So just look at this table. Okay. So this table is about some information about person. Okay. We have ID, name, birthday, gender, is a teacher or not, number of students taught by this teacher, country, city. So this is a very simple table, right? It's not complex with only 10 rows, about 9 columns, right? But there are many issues here. So for IDs, okay, they should be unique, right? For example, this is the identity of each person. Then okay, so we have duplicated IDs. This should not happen, right? We may have format issues. For example, for this column about birthday, right? This value here has different format compared with other values in the same column. And also we may, if we only consider male and female, as you can see for the gender value here, there is an invalid value. There is also missing value for the city here, right? So this Mary, we don't know it's his or her city. And also we may have misfilled values. Italy is a country, right? But it's this value appears in the city column. This should not happen. And we may have misspellings, right? This is a word without any correct meaning, right? And also we may have other issues about data quality. For example, for this one, just look at this one here, right? It includes 2 cells. So for this column, this means if this person is a teacher or not. And this column means how many students taught by this teacher, right? We can see that there's some dependency between columns. So for this ninth row for Annie, so she is not a teacher, but she has 5 students. So logically, this is not consistent, right? So this is also some issue that we need to resolve for data quality, right? If is teacher is the value of is teacher is 0, then there's the number of students should also be 0. This is called attribute dependency. As you can see, there are like 7 issues in this small table. If we have a very big table, there are many other issues. So the next is feature extraction. This is actually the process that we transform raw data into features, mostly numerical, that can be processed. Well, these features should preserve the information in the original data set. Feature extraction is very important, and for the next lecture, we'll spend some time talking about it. The fourth is feature scaling. This is related to something called normalization. Usually we need to put values in similar range so that they can work together. Let's see an example here. So let's see the table on the bottom right. We have this table about employees, right? Age, salary, okay? Apparently, there is for the majority of the employees, they have salary in similar range, right? Well, the last record for that employee 3, maybe he or she the boss of this company, right? His salary is very high, and if you want to take the average of these 4 employees, the average salary is very high, right? But this does not reflect the actual situation. So we need to do feature scaling to avoid this misleading observation. One is called clipping. That is, we specify a range with minimum and max values to say that, okay, we are only interested in the values in this range. For example, we can say that, okay, we are only interested in 10 to 100,000. Then we'll just discard or ignore this record here to avoid outlier. So so that's clipping. Now let's look at this table. We have this 3 employees with this salary, right? So these values, they are in thousands, right? They are very big compared with, for example, the age column. Now we want to maybe put age column and salary column into the same range. For example, in the range 0 to 1. We need to do normalization. So here, we can do this by min-max normalization. That is, we provide its percentage decided by a minimum and a max value in the column. So look at this salary column, okay? So this is the minimum value. This is the maximum value. And for a certain value X, we just use this formula with the minimum value in the column and the maximum value in the column to do the normalization. So after normalization, we will have this scaled salary in these values. All right. So for example, for this 30,000, right? So you just put 30,000 here, and the minimum value is 20,000. The maximum value is 50,000 of the column. Then you will get 0.333. It's a 1/3. This is a scale. This is a normalization by minimum and maximum. We can also have other ways for scaling. One way is to use logarithm operation. So log here. You can just apply original value x by log scaling to get x prime. This is useful for values vary in exponential or in a wide range. Okay. So for logarithm, it's a very simple calculation, right? And next one is for something called z-score normalization or scaling. This is related to the the mean and the standard deviation of the corresponding column. So, for example, for this salary column, if we want to do z-score scaling, first we get the mean of this column and the standard deviation of this column. So we have this mu and sigma. And then for specific original value x, we just apply this formula to get its normalized value x prime. So that we provide a way to understand a values to its relationship with the mean in this column distribution. So if you get the mean of the salary and also standard deviation, applying this formula here, you will get the scaled salary values like this. All right, this is z-score. After preparation, including maybe do some pre-processing about data quality improvement, about feature extraction. After that, we need to analyze, right? To build methods, to apply all kinds of analytical techniques to actually run these methods on our data. So, and then the next step is a report. That is, we want to show our results to our, for example, colleagues or to our customers. Okay. So this is like we need to do some realization about the result to intuitively show the results or our findings to people that may be not technical, right? So it's like when we write a program, right? We just output the results in numbers, right? Maybe we get accuracy 98%, right? We may find that, okay, there's a positive correlation between these two attributes, right? But for non-technical person, they may not be able to interpret these values. So we need to have some visualization techniques. Here are some examples about very popular library or tools for us to do visualization. And actually for visualization is a very important research area. There are many advanced methods for this purpose. And then the next step is act, which means, okay, we get some insight, get some findings from the analysis, from the report. Then we want to, especially in real world application, we may do A/B test, right? We may do some evaluation about its possible impact or for example, will this, how much possibly will this increase the revenue, right? Or the customer attention rate. And for this whole process, it's an iterative process. right? We need to acquire, prepare, analyze, report, act, and then we get new data, new insight we want to acquire, and then do analysis again so that we can improve the whole process, the whole method for the application. But of course, for these 5 steps, we rely on big data infrastructures like Hadoop, MapReduce, databases, distributed computation to support this whole process in order to handle large scale data. And here shows another perspective. So it's the idea is similar to previous slide, but with further more details. So starting from raw data, right? We already explained, for example, video, audio, image, unstructured data, and also structured data in databases, Excel, right? We may do data pre-processing to improve the data quality, to do transformation, normalization, scaling, and then apply certain domain-specific models for recommendation, for fraud detection, for classification. After that, we need to further improve it, which means we need to verify the effectiveness, right? Verify the efficiency, estimate the cost, and try to do prediction, try to describe the data we have, right? And then this can be used for downstream tasks. And for this whole process, this relies on big data storage, computation, infrastructure, distributed parallel settings. Okay. For this one, I'm not going to repeat it because for this kind of a working flow with a 5-step pipeline, you can draw different figures to help you interpret the whole process. Okay. Yeah, you can look at the details, but basically it's similar: capture, process, store, analyze, and use. Okay, and this is an iterative process. It relies on many services, a software platform, and storage to do so. Now let's go to the last part of today's lecture. We want to provide or explain some terminology here. When we talk about data analytics, right? Roughly, there are some, how to say it, we have some goals. Okay. For example, now we have some, imagine that you have a huge amount of data here. You want to know what's that data about, right? You want to know, okay, so what can we find? What can we get from that data? This is more about describing the data you have, right? So this is about descriptive data analytics. So what has happened? We want to get some insight about historical data. Well, on the other hand, if we go one step further, so we have the data, we now understand what it's about, right? What happened. With this, can we predict what will happen in the future, right? Will these two users become friends in the future? Will this user buy product A in the future, right? What's the probability? What's the confidence? So we want to do predictive analytics. So these are the difference between a descriptive and predictive analytics. And this mapping these two to the techniques that we may get in touch. Okay, so this corresponds to supervised and unsupervised learning. So nowadays Many of us say that, okay, I want to build an AI model. I want to build this kind of method. I want to build a learning method or some technique, right? But actually, for all these kind of techniques, you need to be very clear about if they are supervised or unsupervised, because these settings are very different. Okay, so for unsupervised, usually these techniques they are descriptive. For example, clustering, association rule mining, and so on. Well, for supervised, they are usually for predictive analytics to classify users or classify the risk of a certain transaction, to do regression about predicting, for example, the stock price of next trading day. So now let's see some illustration to show the difference between supervised and unsupervised. Now let's look at the figure on the right-hand side. Uh, just suppose that these circles, white circles, they are just your data. Okay, you have 5 data samples. Okay, and so this is the data we have, and we don't know much about it, right? We want to find new insights about the data. We want to know what happened. So this data, they are not labeled. They are white, right? We just run some method, maybe clustering, for example. Okay. And this method, this clustering method may put these 5 records, 5 samples in 3 groups, right? This model say, okay, I can see the difference about this 5 sample, right? I put them into 3 groups. So here use blue, red, and yellow to represent. So as you can see, based on this method, we just use the input data to assign, okay, this color to these 3 groups. We find some new some hidden structure or insight about the data, we can describe it. Okay, so for these 5 samples, they are roughly in 3 groups, like that. And as you can see, this process is from left to the right. Okay, one way from left to the right. There's no external knowledge. There's no label to guide this process. Well, for unsupervised, this means we have some extra knowledge. We have labeled data we have labels to guide the process, guide the processing of this method, this model here. So now we have these 5 input samples, each with labels in color. So at the beginning, we know, okay, we know that for the first, it's in blue, second in red, yellow, yellow, blue. We know the color here, right? We know the labels. And then we want to have this model to work or to train it to make make predictions align with the input data and their labels as much as possible. Okay, we need to do this iteratively, and this process is guided by these labels. And after the training, in the future, if we have some test sample, we wish this model itself can predict the label, the uncertain label as much as possible, as accurate as possible. Okay. So as you can see, for unsupervised, we have labels, not only the data, but also labels on the data. And also we have this feedback. We want to predict something. So this is the difference. So the left-hand side, this process is supervised by the labels. Okay. On the right-hand side, there's no such label information, and it's one way. So for supervised approach, here shows further details. So if you have a data set, usually you can, generally speaking, in the simple case, you can just break it into training set, test set, right? And for the training set, you use it to train this model with some training algorithm. Okay, so there are many optimization algorithms for parameter training. And after training, you can use this model to be evaluated on the test set. So now let's see some example about supervised learning. So first, here is about regression. So for regression, the idea is to predict a continuous or real value. So for example, we want to predict the stock price or the housing price of next month. Okay, so will this be 200 or 200.3, right? This is continuous value. We want to predict that. Well, for classification, that is to predict a discrete value. It's like a categorical value, right? We predict, for example, will the price go up or go down, right? So this is a categorical value. We want to decide if this email is spam or not, right? So we have two labels to predict: spam, not spam. And also for object detection, that's also classification. So suppose that now we have an image, right? We want to predict if there's a cat or not in the image, right? Cat, not, that's two classes, right? If we want to predict if there's a cat or a dog or a giraffe in the image, that's three classes, right? Well, for unsupervised learning, as we mentioned, it's one way, right? Without extra supervised information. For example, clustering, that is to determine or put the data samples into different groups. And there's one clustering algorithm called k-means. Okay, it actually try to, on the right-hand side, we have these data points, okay? And we apply cluster algorithm so that at the end, we put them into four groups, okay? In red, green, blue, and black, okay? So this color, this cluster or cluster membership, they are assigned by this algorithm, okay? They are not the input. Okay, so I think that's all for today's lecture. And here, there is you can scan this QR code. This is also available on the slides that you can download from a Blackboard. There are some very simple survey questions to try to get your get your background and also some feedback. So if you are interested, you can just have a look about it. Okay, try to know your background. Okay, so that's all for today's lecture. Okay, so if you don't have any questions, I'll see you next week. If you have a question, you can ask. Okay, thank you.